I'm not going to use the microphone. Can you hear me? Hear me okay? Here Technologies is where I'm working now. I worked at PG&E immediately before that. What does Here Technologies do? Nothing. Doesn't do anything at all. That's what I'm doing. I'm the strategic manager for that. That's at 30 frames per second. That is categorizing the poles, the signs, the lane markings on the left-hand side in real time. It's positioning them in the neighborhood of 5 centimeters plus or minus at about 98% reliability. Now, on the right-hand side is classification or segmentation. Obviously, we're getting vehicles that are segmented, pavement, which is drivable area, also the lane markings of the poles, and the places that you cannot drive, for example, the mountains. This is what's happening at Here Technologies. Now, the point about this thing is, that I would like to explain to you, is that the way this works is that there's mapping, and then there's sensors on the car. Now, a lot of people are doing autonomous driving with just the sensors, and they're running into stuff, and things aren't happening too well. The idea here is that you've got the map, and you've got the sensors on the car, and the two are going to be correlated in real time in this way. That's what's happening. This is called highly autonomous driving, and in a couple of years it's going to be fully autonomous driving. Now, this is being built custom by people who build robotics technologies and so on and so forth. And of course, what they do is they accept the data as it comes in. They're not too terribly concerned about the source, but they're using stereo imagery, they're using LiDAR, they're using GPS, GNSS, they're using odometry, and they're fusing it all together in a bus, and then it's going up through the LTE to a centralized database in the cloud. Then that database is then going back to the car so that the map is updated. That's the way the system works. It's called the closed loop. Now, this closed loop is something that is being achieved right now. But I'm the guy who is at the front end and talking about the data that's coming in. I can't say enough about the people who are building this code. I didn't know that I was going to live to see this at 30 frames per second and 70 miles an hour in real time. But this is what they're doing. So, that's what Here Technologies does. And that's what I'm currently doing. So who do I represent? Highly autonomous driving mappers, which is, as I said, there's mapping involved with this. Surveyors, I've been a surveyor for 56 years. And when I started in 1963, I'll tell you honest to God, I didn't much care what U.S. Coastal Geodetic was doing because I was working in assumed coordinate systems. Now, when I started doing GPS in the early 1980s with the macrometer, which was the first civilian GPS receiver, I cared a lot about what NGS was doing, and I have to say, I'm proud to be here because I've always thought the world of NGS ever since then. You guys have bailed me out more than once. I remember the days when I had to call up on the telephone to Silver Spring and talk to a clerk who would help me pull the records. I've got nothing but praise for NGS. GIS professionals. I helped build the GIS for Quest Communications, which is the telephone company in the western states. I also was the architect for the PG&E, which is the largest GIS data set for utility in the world. And so I talk for GIS professionals as well. Industry vendors, I rely on them, all of them. You got it, I rely on them. I use every tool that I can get my hands on. Surveying, of course, GIS, of course, terrestrial mobile laser scanning, sure, photogrammetric, hyperspectral I want to mention. Don't forget hyperspectral in this context. UAS, of course, cell phone vendors, real-time network providers and software developers. That's the stuff I use, and none of it works well enough. Frankly, the thing I'm up here to say is that as that video shows, the technology is moving at an incredible pace, even faster than I have thought. And I'm the guy who used to run up to people on the street, grab them by the lapels and say, GPS is going to change everything. And they'd pat me on the head and tell me to go away. This was about 1983. And then about 5 or 6 years later, I said, GIS is going to change everything. Same thing happened. And then I said, you got to put the two of them together, and now you're really going to have something. And what I'm here to tell you is this autonomous driving stuff, it's going to change everything, including what's happening at NGS, or at least, let me put it this way, I think it should. Here's the way the autonomous works. That car up there with the red lines to it will have all these sensors I was talking about. But that's not good enough, because that is creating what is known in robotics as a pose path. As it's going down the road at increments of usually 10 megahertz or faster, it's what you can think of as producing points. Now you could think of those as reference points. Then what's happening is that by what they call triangulation, it isn't exactly that, the other sensors, including imagery and other things, are collecting features of interest. For example, poles, signs, everything along the roadway. This is what's going to get in that closed loop and go back up to the map. It's collecting those in real time. Like, for example, let's suppose there's a construction site that wasn't there the last time they drove this road. Well, what's going to happen is instead of that correlation happening, the mapping isn't going to have it anymore, so it's going to rely entirely on the sensors. As the sensors are, it's leaving the map behind and collecting the data from the sensors and pushing it back up to the map, so that the map updates itself and then pushes that down to the car that's right behind it, so that when it goes through the construction site, it can rely again on the map. Now remember, I'm talking about levels of accuracy and speed at an incredible pace. This is the way it has to work. Now, of course, as you all know, it isn't enough, because you have to have a system whereby you're referenced to a truth set. And that truth set is going to be represented, let's say, by a continuously operating reference station. But even that isn't enough, because as you all know, that reference station doesn't exist by itself. It's part of a very much larger network, like the Coors network, so that we've got a consistent, homogeneous system across the entire continent. And even that isn't enough, because there are private, subscription-based real-time systems that aren't necessarily in line with everything else, and this is not North America, this is the world. Here has mapping for the entire globe, all of the roads. But there's a distinction between the mapping that's used for navigation as you use in your car to go from this address to that address, and the mapping that's called the High Definition Live Map, HDLM. That's the map that's going through this closed loop that I'm talking about and is crowdsourced. Now, that crowdsourcing doesn't start with fleet vehicles, it starts with mobile mapping vehicles, of which I'm sure many of you are aware. These are the vehicles that have the high-level sensors that are driving these roads first. I wrote my dissertation on this a decade ago. But now, what's happening is you cannot drive all of the roads in the world with this fancy sensor. And so it's the crowdsourcing that's going to build the map and make it sustainable over time. PG&E, this is just one slide, I can't show you much. PG&E is a public utility because you wouldn't want a private utility supplying your electricity, your water, your gas. There are such things, but they're usually public, private, and highly regulated. There, you see over here on the left, 3 million. That's 3 million support structures. That's just poles. That's an incredibly large database. But here's what's happening right now. Those folks are using cell phones, for example, and going out and collecting data on poles and transformers and other things using the GPS that's on the cell phone and putting in attribution to update their mapping. Now what they'd like to do is they'd like to take that data and put it right back into the GIS system. Can't do it. Why not? Because the data in the mapping isn't matching the data that they're getting out in the field for all kinds of reasons, of which I'm sure everybody here in this room could figure out for yourself. That's fine when you're talking about static data. You can live with it. You can find a way around it. But not when you're driving down the road at 70 miles an hour. This is pretty slim, I know. Frequently use ASRS to get some course data once in a while. Don't use it much. Why not? I have to rely on subscription services for real-time correction. I hate that. Geospatial products and services I frequently use end-to-end GPS, GNSS, IMU, because of course you're going to use a inertial measurement unit, and of course GIS software. I think there ought to be an NGS real-time network. And I told by some friends here who I talked to, I said, "It ain't never going to happen." Well, why isn't it going to happen? Well, because NGS is not in the business of competing with folks who do vendor subscription real-time networks. And I know there are many, and I use most of them. All right, here's the case why I need this, and I need it badly. First of all, through no fault of the own of people who make their money as a private enterprise, your objective is to make a profit and to make a profit for your shareholders. I can hardly blame people for doing what they have to do. That's important. And that has to be the overriding consideration. The second thing about that is, while even best efforts to make these real-time networks fit together on a homogeneous scale across large areas, it's difficult. Even under the best of circumstances, it's difficult, and I know NGS would like to facilitate that. But folks, I'm talking about the cars driving down the highways. I can't post-process this stuff. I can't use the course stations, for Christ's sake. I need a real-time solution that's homogeneous across the continent. Like I said at the beginning, I've got nothing but good things to say about NGS. I think this is one of the government agencies that has done a remarkable job over decades. I need your help. Second thing, after NSRS modernization, I have this question. How should organizations with large databases make positions in those databases coincident with the new horizontal and vertical datas? How should they maintain those coincidences in the years that follow? When I'm talking about PG&E, when the modernization happens, they could, of course, transform all of their data into the new system so that they can use these folks that are out in the field collecting the data as I described and put it into their database. They could do that. But as you know, since it's going to go to an active system, it's not going to be based on passive. As time goes on, what's going to happen is that there's going to be a divergence between what's being collected in the field and what's in the database. Now, in talking to a colleague of mine, yes, on ingestion, there could be a transformation that would keep it at a specific chosen epoch. That's not realistic, folks. But I will freely admit to you, I do not know the answer to that question. And it's a very big, from my point of view, very big question. I don't know how you're going to do it at PG&E and places like that. I'm not saying it's impossible. It's not impossible. I just don't know how I'm going to do it. I'm done.